Okay, so in this lesson, we're going to talk about domain and range of a quadratic function. So we're going to start with a review of what domain and range are. You should remember domain is the set of all the possible input or x values of a function. Range is the set of all the possible output or the y values of a function. Okay, so for a quadratic function, the domain is always all real numbers. Here's why. If I take a quadratic function, let's say y equals x squared minus 4, I can choose any domain value, any x value. Let's do, if I know x is 2, y would be 2 squared minus 4, which is 0. Or if I do negative 2, that's also 0, right? The point being, I can take any real input and I'll always get a real output, okay? Versus, here's something that would have what's called the restricted domain. And this is not a quadratic function, this is a square root function. Let's say we had y equals square root of x minus 1. And let's see what happens if I do my input as negative 3, if I try to use negative 3 for as the domain value. So y would be square root of negative 3 minus 1, which is square root of negative 4, which of course is 2i. And 2i is not a real number. Okay, so the input negative 3 gives me an output that's an imaginary number, which is not part of the real number system. So we have what's called a restricted domain in a square root function, and we'll look at square root functions next when we're done with quadratic functions, okay? But for our purposes, for this lesson, the domain of a quadratic function is always all real numbers. So, number 1, we have the graph, and again, the domain is all real numbers, okay? No work to do there. For the range, again, we're talking about the y values. Well, we need to look at our smallest y value, which is going to be negative 1 here. And then the y's get larger and larger, because remember, these arrows mean it extends infinitely. So we're going to describe the range here as y is greater than or equal to negative 1. I think I said 1 before. It's negative 1, all right? So the lowest y value on the graph occurs at the vertex, which is a minimum value here because we have a smiling parabola. Okay, number 2, for the range, well, we have a maximum here because we have a frowning parabola. The maximum occurs at y is 7. The largest y value is 7. We go from 7, our y values get smaller and smaller. They shoot down to negative infinity, right? So we'll describe that range as y less than or equal to 7. And of course, the domain is going to be all real numbers. Okay, for number 3, we don't have a graph, we only have the function. So we'll go into Desmos. There's the graph of y equals negative x squared plus 4x plus 3. Okay, so we're gonna see that the largest y value is 7, so we have 7 and everything less than 7. So our range is, again, it's going to be the same as before, y less than or equal to 7, and our domain is all real numbers. Okay, So in number 4, of course, f of x is the same thing as y. So y equals 2x squared minus 3x plus 1. Okay. So here, I'm going to click on the vertex. It's going to tell me that my smallest y value is negative 0.125. Again, when we're doing range, we don't care about the x value because range only refers to y values. So our smallest is negative 0.125, and then we're going up from there. So the range would be y greater than or equal to negative 0.125, and of course the domain is all real